Welcome learners. This is Dr. T. Gangaram, lecturer in statistics, SVA Government College, Srikalahasti. In this video lecture, we will discuss the numerical integration Weddle's rules. By substituting n is equal to 6 in general quadrature formula, we will get the Weddle rule. The only condition is the n must be equal to 6. We discussed these things in the previous lecture. The basic idea behind derivation of general quadrature rule is, let us assume that I is equal to a to b f of x dx. By dividing the integral into n equal parts, the h is equal to upper boundary minus lower boundary b minus a by n. Then x becomes x is equal to a, x1 is equal to a plus 1h, and so on. Xn is the upper boundary, last part b. So we need to divide the total integration from a to b into n equal parts. Then the y values becomes y naught is equal to f of x naught, y1 is equal to f of x1, and so on. Yn is equal to f of xn. First we decide the number of intervals to be divided, and then we find h. By adding h values to the a value, we will get the remaining values up to last value b. So the change of variable u is equal to x minus x naught by h. From this we will get dx is equal to h into du. Then the x becomes x naught, and at x naught u is equal to 0. Similarly, at x is equal to xn, the last value u becomes n, and the integral becomes x naught integral x naught plus nh f of x dx is equal to h into 0 to n y du. Instead of y, we will substitute the Newton forward formula. This is Newton's forward formula. Substituting this into integrals h into the series into du, then I becomes h is equal to 0 to n y naught to, this is Newton forward formula du. Now let us integrate the terms. Term wise, 1 into du becomes n, and u into du becomes n square by 2. So on the third term, 1 by 2 into n cube by 3 minus n square by 2 up to next term. This is next term. We are discussed this in the previous lecture. This is the general quadrature formula. By substituting n is equal to 1 in this general quadrature formula, we will get trapezoidal rule. By substituting n is equal to 2, we will get Simpson's 1/3. And by substituting n is equal to 3 in this general quadrature formula, we will get Simpson's 3/8 rule. Now, the Weddle rule is obtained from Newton quadrature formula by taking n is equal to 6. The condition is the number of subintervals must be a multiples of 6. The general form up to 6 intervals x0 to x6 f of x dx is equal to 3 into h by 10 into y0 plus 5 into y1 plus y2 plus 6 into y3 plus y4 plus 5 into y5 plus y6 up to 6 intervals. This is the formula. You need to remember this for applying this Weddle rule in your examination problems to evaluate the given integral functions. For larger intervals, the multiples of 6, the Weddle rule becomes x0 to xn f of x dx is equal to 3h by 10 into y0 plus yn, the beginning value and the last value, plus 5 into y1 plus y5 plus y7 plus y11 plus y2 plus y4 plus y8 plus y10. Next is 6 into y3 plus y9 plus y15. Like that, the for larger intervals, larger multiples of 6, this is the Weddle rule. Next, one example is evaluate 0 to 6 1 by 1 plus x square dx using Weddle's rule. Divide interval into 6 equal parts. 6 minus 0 divided by n is equal to 6 here. 6 by 6, h becomes 1. Then our x values must be, this is 0 is the beginning value, plus 1, 1, plus 2, 2, like that. 0 to 6 are the x0, x1, x2, x6 values. Our function is y is equal to 1 by 1 plus x square. We need to substitute the x values in the y to get f of x or y values. This is the table. By substituting x is equal to 0, y is 1. By substituting x is equal to 1, y value is 0.5, like that. By substituting x is equal to 6, the value of y is 0.027. Now substitute these values, these y0 to y6 values in the Weddle rule. The numerical calculation becomes like this, and the final answer is I is equal to 3 by 10 into 4.5783. Our value becomes 1.3735. This is the evaluation of 0 to 6, 1 by 1 plus x square dx. Let us test it with the integration. 0 to 6, 1 by 1 plus x square dx is equal to tan inverse 6. From tables it is approximately equal to 0.4056. So Weddle rule gives very close approximation. Let us conclude our lecture. The Weddle rule is more accurate than Simpson's rules, and it is applicable when n is multiples of 6. Useful for higher precision numerical integration. Thank you.